And I'm almost, hesitant to be talking on this subject here. We've got all of these nice fruits and vegetables out here, very, very wholesome, very tasty and so forth, but there can also be this side of it where we've got to address, what could be potentially on those commodities. What I've put up here is just looking at the number of foodborne illnesses that might be linked to the consumption of produce. The other thing that I've indicated are just some of the microorganisms involved. And so there's a plethora of these microbes out there that are pathogenic to humans, but there's only a few of them that are really prevalent, if you will, when we look at some of these outbreaks. And then finally, what I've got listed down here is microbiological safety and quality of leafy vegetables can be improved through washing. Wash water can serve as a vehicle for microbial cross-contamination of a product. And so I think that's really what, was driving us, is that we're looking at this. If you're doing any type of washing of your commodity, and more than likely these commodities that are out there, whether or not they're conventionally grown or organic, are going through some type of a washing process. And so how does that impact the microbial quality of that? So for the students out there, and there's a couple of you, this is a really lousy slide, of course. There's way too much information on it. But my point behind some of these slides is that this is the FDA guidance that was put out a number of years ago on the microbial safety hazards of leafy greens. And one thing that they're pointing out here is that ensuring that sufficient concentrations of approved water disinfectant are present to reduce the potential for leafy greens to water to leafy green cross-contamination when water is used to wash those leafy greens. So again, this is looking at the potential for water to serve as a vehicle for the transfer of those microorganisms. They go on further down here to indicate that ensure that the wash water disinfectant used is effective in reducing the potential for water to leafy greens cross-contamination. And really what that all gets back down to is whether or not, if just because you're putting in a water antimicrobial, is it actually efficacious? Is it having any impact on the microbial load in that water? And then finally they go on further to state that wash water disinfection demand, product to water volume ratio, these types of things need to be taken into consideration. Again, this is looking at from the commercial side of things. And when we were interested in conducting this research, we did a literature search. And what we found is that there's very little research that's associated with what's going on in food establishments with respect to how they're handling these leafy greens, what's going into the water if they're using an antimicrobial, and really looking at cross-contamination. If you're working in the food industry, you're probably aware that there's a lot of research, particularly in supermarkets, looking at the deli side of things, and cross-contamination of deli meats when they're processing them there. If you go and you start delving in deeper, you'll see that I don't think there's one paper we found looking at what's going on in the produce area of the supermarket with respect to microbial food safety. So that's in the literature I'm talking about, not necessarily what companies and so forth are doing across the board. So the issue here then is cross-contamination. And again, most of this research that's out there is looking at commercial processing of leafy greens and other commodities. If you look at this water antimicrobial, so what are their job? What do you put in water antimicrobial in there? Well, it's to control the microbial load in the water. So it's from a commercial standpoint, they'll put it into the flume water when they're washing, let's say their chopped lettuce, or they're washing their baby greens, what have you. And that's to mitigate cross-contamination. So you want to control that microbial load. I mean, even if you wanted to move outside of the realm of fruit and vegetable processing, if you get into the canning industry and their cooling towers, they're putting antimicrobials into those waters in order to control the microbial load there. One of the benefits of all of this is that you get a reduction of microbial load on the commodity. So that might well be pathogens or commensal microbiota. So this would be looking at those organisms that are involved in spoilage of your product. So now I bring up the Fda Food Code. And this is really looking at, not really, it is looking at what's going on at the retail level. So if we look at this under 3-302.15, washing fruits and vegetables, I want to draw your attention to this underneath paragraph A. Except as specified in paragraph B of this section, and except for whole raw fruits and vegetables intended for washing by the consumer, raw fruits and vegetables shall be thoroughly washed in water. So you could use running water to wash your commodity, and that would be perfectly acceptable, and that's what many folks do. What I want to go on here further, though, to indicate is that under section B it says fruits and vegetables may be washed by using chemicals as specified. And really what this would be looking at is putting those commodities into a bath, so into a sink or some type of container, and then washing them there. Now I know when we've looked at this, people try to equate, well, what's going on from a commercial standpoint with what you're doing in a food establishment. And I don't think you can equate those, because they're very, very different processes that are being utilized there. So the area that I wanted to touch base on through the research that we're doing is looking at washing and crisping. And there are a number of different documents that are out there, public documents, the California Department of Public Health Retail Fruit and Vegetable Guide, Defense Commissary Agency, so this is part of the military looking at this. Then finally, FMI, back in 2014, put the Produce Safety Best Practices Guide for Retailers out there. So what do these documents have to say with respect to processing as far as washing and crisping is concerned? And I'm assuming that this whole group here knows what crisping is, but just in case if there's a few folks that aren't aware, I'll go over that briefly. So if you look at California Department of Public Health and their guide here, they indicate considerations about leafy produce, room for trimming, soaking, and crisping these items. They go on to further indicate that a vital process that will revive wilted leafy greens and almost triple their shelf life. I don't know about this part here. I don't know whether there's research to support that or not. Again, you folks are in the industry, so you probably know better than I. They go on further to indicate that lukewarm water for about 15 to 20 minutes. Again, these practices vary significantly from operation to operation. Whether it's going to be 5 minutes or up to 15 to 20 minutes, I don't know. I know a lot of folks that are doing this, they might not be utilizing lukewarm water. They're using whatever that water temperature is coming out of the tap. Finally, down here, prep an entire box of leafy greens using trash can for the trimmings and a bucket of clean, drinkable water for soaking. So again, they're not talking about putting any antimicrobial into that water. I'm assuming they're indicating that it is indeed potable water. But that's not going to control the microbial load that you're going to get from commodity going in there. So the Defense Commissary Agency, what do they put in here? Crisping is a process that improves and preserves leafy vegetables. And again, more than just leafy vegetables can go through a crisping process by soaking them in cool to warm water and placing them in a cooler to crisp. So a lot of the research that I want to present here today is looking at that first step of crisping, where you would go through and immerse your product in the water, so you'd be soaking it, then you're going to take it out, put it into the cooler for that crisping process. So maybe submerged or washed in a sink, and then soaked in water for a minimum of up to 20 minutes. So that's a long period of time to soak a product, but again, depending upon what's going on in that room within, let's say it's a supermarket. And again, it could be a restaurant as well. And then finally, FMI, what do they suggest? Well, for crisping, ensure that the sink is cleaned and sanitized before and after crisping. I have to say that of all the documents I've looked at that go over that soaking process, if you will, or crisping in general, this one here is the most specific with respect to cleaning and sanitizing that sink to ensure that you're not having that as a source of microorganisms. If a bath is used, follow sanitizer recommendations. So they're suggesting that indeed you should use a sanitizing agent, so a water antimicrobial, to control that microbial load in the water if you're going through and using a bath, so i.e. putting it into a sink. Finally, down here, if using a bath, an appropriate sanitizer should be used in compliance with label directions, as they've indicated here. And then they go on and talk about some other measures here, which all are going back to ensure that you're not getting cross-contamination or contamination of your product as one moves forward. So, as I said, we're doing research in this area, and it's not as though I'm here to just promote what we're doing. It's just that, as I've indicated, we went through the literature and we found that there was very few papers out there discussing what's happening at the retail level. And I know as well that, oftentimes companies or retailers, they're not wanting to share some of the information. In other words, what are their standard operating practices, or what are their best practices for doing some of these operations. But what we tried to do was several studies here looking at different commodities. So we worked with cantaloupe, we worked with lettuce, and we also worked with cilantro. And what I'll do is I'll share a little bit about each one of these studies to kind of set up this last piece of research that I want to talk about. And again, I know this is a little bit different from some of the other presentations that were here today, and that we're probably going to get into a little bit more technical information. So if we look at this first study that I want to go over, Sanitizer Efficacy in Preventing Cross-Contamination of Heads of Lettuce During Retail Crisping. So again, I'm looking at this mainly what's going on, let's say in a supermarket. What are they doing here? And so I'll walk you through this a little bit, because this way here we can utilize this information as we talk about some of the subsequent studies. The bottom line to this is that we had one head that was inoculated with approximately 5 log CFU per gram. And the organisms that we were using down here were Salmonella, E. coli O15787, and Listeria monocytogenes. So what we wanted to do is we wanted to inoculate one head of lettuce with these foodborne pathogens, and then put it into a sink with 7 non-inoculated heads of lettuce. And we had different treatments here. So in this 76 liters, so this was a standard size stainless steel sink that you would find in either a restaurant, or you would find it in a supermarket. And it was filled about probably 3/4 of the way filled, 2/3 of the way, somewhere about that. So that works out to about 76 liters. We used tap water, electrolyzed water, and then we used 2 different acid-based antimicrobial agents. This is a lactic phosphoric acid, and this is a citric acid based. And we soaked for 5 minutes. One of these things before, as you were reading, they said 15 to 20 minutes. And again, we can control it very, very succinctly because we're doing research. I would imagine that if you're in a retail operation, person's throwing it in there, yeah, it's probably going to go for more than 5 minutes. But if you're trying to rehydrate that product, it can happen within 5 minutes. Then what we did is we took 2 subsequent batches of 8 heads of lettuce, and we put those into that same wash water, or that water that was in there. We soaked those, and then we started looking at what was going on with these microbial populations. And what we found is that in this case here with the electrolyzed water, we had reductions in our population of all of these pathogens that we had in association with it. Bottom line here, we saw prevention of cross-contamination when we were using these sanitizers in here compared to tap water alone. So the take-home message here was that we were getting prevention of cross-contamination. We were also controlling the microbial load in the water. So another study that we looked at, and this was looking at whole and fresh cantaloupe. So again, this kind of goes back into that outbreak that was back in 2011 with the cantaloupe and Listeria monocytogenes. and looking at, well, if you're processing cantaloupe, whether it's in a restaurant or you're doing it in a supermarket, you're cutting that cantaloupe open, you're turning it into cubes, what's going to happen? So in this case here, we utilized those same types of sanitizing agents, and we had a whole cantaloupe, and we dipped that into a cocktail of either salmonella or El Mono. And again, looking at this case here, it was the surface, so it was a centimeter square that we were looking at. So we had 1 inoculated and 2 inoculated whole cantaloupes. And I would imagine that if you're doing this at the retail level, you're putting more than 3 cantaloupes in the sink at any one time. We recognize that. It was just for the purposes of trying to process this and do all the sampling that we had to put it down to that. And again, that's why I'm saying that even on this, one of the pushbacks that we had when we went to publish this is people were saying, well, from a commercial processing standpoint, this is ridiculous. Well, again, we're not dealing with a commercial process. We're dealing with something that might be done in a restaurant or it might be done in a supermarket. So we did this for 5 minutes, so the whole cantaloupes were put in there for 5 minutes, and then what we did is we cut those cantaloupes up and we got the flesh from those cantaloupes. And we went through and we treated those flesh from inoculated and non-inoculated cantaloupes were soaked together. And we did that in those same type of sanitizers. It was fresh sanitizing solution. And we did it for 90 seconds. So the intact for 5 minutes, the cut pieces for 90 seconds. And then we looked at it. And what we found here is electrolyzed water, approximately 1.5 log reduction of the salmonella and El Mono on the rind of the cantaloupe. So it reduced what was on it. Cross-contamination of non-inoculated whole cantaloupes occurred when washed with inoculated whole cantaloupes in the water and in the acid-type sanitizer. So again, what we found is that those 2 non-inoculated cantaloupes became contaminated with these pathogens just by putting them into the same water. And you're trying to wash them. And then what we did is we did washing of the mixed fresh cut cantaloupe flesh from the inoculated and non-inoculated cantaloupes prepared after washing of whole cantaloupes resulted in cross-contamination. So this study was a whole mess of crosses back and forth. Ultimately, what we're indicating is that we were able to detect at extremely low levels that when you prepared the cantaloupe cubes from the inoculated cantaloupes and even from the non-inoculated that were cross-contaminated, those cubes were contaminated once you went through and did this final processing. So, but at very, very low numbers. We had to use an enrichment process. So we couldn't say whether there was 1 cell or 100 cells there, but the bottom line is the organism was there. So the final one I just want to share with you is the one that we're doing with cilantro. And we wanted to do cilantro from the standpoint that it's a bunch rather than, a head of lettuce, whether it's a red leaf lettuce or it's a romaine lettuce. It's not an individual commodity like you might have with a tomato or a cantaloupe. So we looked at also cilantro from the standpoint that it typically has very, very high levels of microflora. So in this case here, cilantro carried high populations of natural microflora, around 7.4. Nothing wrong with that from the standpoint that you'll often find in some of these commodities high levels of a microorganism. So what we did here is we took this, we inoculated a bunch with either Salmonella, E. coli 015787, or El Mono. We did our treatments just like we did before, 2 additional soakings with these non-inoculated. And ultimately what we found is that during the first soaking, significantly greater reductions in Salmonella, E. coli, and El Mono on the cilantro were achieved with the electrolyzed water compared to just soaking in these other tap water alone. So again, this is demonstrating this whole cross-contamination phenomenon and why we need to control things. So if I haven't put everybody to sleep yet, we're trying to get to where we want to go to. So some of our process considerations, things that we're thinking about from the retailer standpoint. or from that food establishment. Low versus high volume. So again, in these studies that I just talked about, people are going to be putting in more than 8 bunches of cilantro or more than 8 heads of lettuce at a time. They're probably going to be doing a whole case, so 24 heads, let's say, of lettuce at a time, realistically. And again, you folks would know better than I, and I would look for guidance from you if you'd want to share with me as far as what might be a typical volume. But this is just from some of the talks we had with folks indicating that they might do upwards of a case. So we wanted to do more research, and what we decided to do is we were doing our 8 heads per sink. We would kick that up to 24 heads per sink. So again, higher volume up here. And what I want to stress again, that often the criticism of this type of work is that, oh, well, you know, we know all about this because it's the same thing that's being done in a commercial processor. And it's really not. If you guys have gone to any of the commercial processing facilities or you're involved with them, it's totally different, you know, as far as the volumes of water that they're using, the types of processes for their commodities. The other thing, number of times that water's being used. So we used it 3 times, figuring that you're not going to go through, fill a sink, drain it, fill a sink, drain it. You're going to use that to do several batches. The other aspect of this is whether or not you refresh that antimicrobial. So between each batch, if you're testing it, are you saying, okay, if it's an acid-based antimicrobial, if it's gone above pH of 3, do I need to adjust it back down below that? If it's some type of a chlorine base and you want to have, say, 40 to 50 ppm of free chlorine, are you still at that, or are you going to refresh it? So what are you doing there? The other thing was contact time. As I said, if you look at some of these documents, contact time is all over the place. We've selected 5 minutes because we felt, well, if you were trying to achieve, if it was a washing process, you could easily do it in that time. If you're doing a crisping, you could get the desired effect that you'd want in that amount of time. And again, on some of our studies, we're looking at this with the crisping. So in other words, you're soaking your product in that water. You've increased the weight, let's say on a per head basis, by about 10 to 15%. So in other words, it's taking in that water. And of course, when you're doing this process for crisping, you're removing a thin slice of that butt end of, let's say, the lettuce head, so that it will allow that free flow uptake of water. The water temperature. Most of the time I'm looking at this and I'm seeing, well, people are simply turning on the faucet and they're filling the sink up. Or even if they have an automatic dispenser. So whatever that water antimicrobial is, it's hooked into the faucet and they're using whatever water temperature that is. Now I know some folks might actually pour ice into it. So they might be doing other things that would bring down the temperature, but again, it can be variable. And then finally, the chemical antimicrobial. What is it that you're going to use? And I'm not trying to promote one antimicrobial over the other. All I'm suggesting is that there's a real plethora of antimicrobials out there that can be used in water. What do you believe is most effective, and then why do you believe that? So just kind of looking at that aspect to it. So here's our process that we have here. We have these 4 sinks, and the reason why I bring this up is that what we do when we do the research, we do it all at one time. And so therefore, there's not going to be variability from one batch to the next. And I think you folks realize that if you go out and you're looking at lettuce or you're looking at any commodity, literally from field to field, the microbial loads can shift. And so we wanted to be certain that if we're doing this, we're having the same commensal load on our commodities across the board, and that it's also coming out of those same batches. So we'll do our water, and we'll do 3 antimicrobials all at one time, process everything like that. And you can see we've got even hooked in here so we can dispense some of these automatically right into the water. Just to reiterate, I always joke about this, well, it's added protein, but the bottom line is if you look at the microbial load on fresh fruits and vegetables, And some people are shocked by this, and I don't think people in the industry are shocked by this, but I think many times consumers, if they were to read this, might be shocked that if you would say to them, well, if you're looking at fresh cut vegetables, this is log 9 CFU per mil. So you're looking at millions, tens of millions, hundreds of millions of bacteria associated with that commodity. Does that have a human health impact? Probably not. I mean, unless there's a pathogen there, it's not going to affect you one way or the other. Would it have a potential negative impact on the shelf life of your commodity? Well, perhaps. But really what I wanted to do is just to give you the sense that it's a huge variability with respect to the microbial load on some of these commodities. Yeast and molds, again, looking at spoilage of your commodities. Enterobacteriaceae, so that would include some of your pathogens of interest here. But the bottom line is it's a huge variability. So what I want to do now is to go into some of the research that we conducted approaching this whole concept of low versus high volume. Again, as we listen to some of the folks that were reviewing our papers, and then when we went to different, talking with different individuals, they were suggesting to us, well, it's probably highly unlikely that you're only going to be processing such low numbers of a product, so why don't you kick that up a notch? And that's what we decided to do, but we decided to try to keep the same scenarios that we had done in the past so we'd be able to use that as a reference. So we have the low volume here, which is our standard of the first soak with the 1 inoculated, 7 non-inoculated commodities. And in this case here, the project that I'm going to talk about is lettuce. We then moved down and we did our second and third soakings of 8 non-inoculated. So what we want to know is we want to know if that first one had pathogens on it, would that carry over if you're using that water subsequent times? And so that's why we address that. Then over here we've got the high volume, and basically we're looking at a total of 24 heads. So this is basically if you were to take the whole case and dump it in, what would happen? And then finally doing a second and third soaking. So the sanitizers that we are using here are all commercially available sanitizing agents. We had a lactic acid, phosphoric acid, which I'll refer to as an S later on. We had neutralized electrolyzed water, which had a free chlorine around 40 to 50 ppm. And then we had a sodium dodecylbenzene sulfate acetic acid. And then finally, our good old New Brunswick tap water. So the bacteria that we're utilizing in this particular study, we decided to look at the S-Tex. So before, we were mainly concerned in just utilizing 0157H7, but I think we all recognize that if we look at some of the illnesses, they're due to these other serotypes as well. So there's a lot of these Shiga toxin producing E. coli out there. We wanted to utilize those, and we used ones that were associated with produce-related outbreaks. We then looked at Listeria monocytogenes and again tried to use ones that were produce-related outbreaks. You know, there's a lot of, if you will, pushback from the standpoint, well, you know, there's been no data really collected on looking at, well, are there foodborne illnesses related to the way product is processed at the retail level? You know, can you document, you know, an outbreak associated with that? No, it's very difficult to. As a matter of fact, there's very little data to suggest, well, if you're looking at commodities going into a supermarket or restaurant, you know, what percentage of those are potentially contaminated with a foodborne pathogen? I have no idea, and I don't know if there's any data out there on that side of it. The other side of that is if you're processing it in a restaurant or if you're processing it in a supermarket, you know, is there any data there which would suggest that there's foodborne illnesses linked to that? And again, there's not good data on that at all. So that's one of the things we have to be concerned with when we're looking at this, is people might be saying to us, well, is it really even a concern? The other thing being is that when you think about processing commercially, you could take one head of lettuce, chop that up, blend it with 500 heads of lettuce, and it kind of gets back down to the ground beef phenomenon, right? Where you get one piece that's now commingled with all this other lettuce, so now you could have, 500 bags of lettuce contaminated as opposed to just one head. And so that's what, there's pushback here. Well, what's the likelihood of that one head causing a problem? And that's what we're trying to suggest here, is that you could have one head and it could actually contaminate many, many heads of lettuce. The other thing would be is, well, where could this bacteria be coming from? And I would suggest that it doesn't necessarily have to only be in association with the product coming into your facility. And I think everybody here recognizes that it could be the workers, your employees. We know this is particularly prevalent if you're looking at viral type of contamination. So if you're looking at where you have a norovirus, that's probably a worker with dirty hands handling things and contaminating your product. The floors and sinks, the cooler, all of these things could actually be a source of contamination. And I noted back there that the sink hasn't been cleaned and sanitized appropriately. Or are you getting residual microorganisms or the ability of microbes to actually grow in that type of environment? And even the cooler, I think we have to keep in mind that these guys right here, Listeria monocytogenes, does what? It grows at refrigeration temperature. So you can literally have this in your environment, and that can be growing, increasing in numbers, and now you put your cases into the cooler, you're inoculating those cases, you're putting them on top of each other, and now you're dumping it into your sink. So all of these could lead to contamination. So what I want to do is to go ahead and work through this as fast as I can, just to say that we did a low volume and we did a high volume, and again, we did 5.5 log, as I've told you before. We did the 8 heads versus 24 heads. We had the lettuce here, and we processed that. We also processed our water as well to look for microorganisms in the water. So what did we end up with here? So this is looking at log reduction of aerobic commensal microbiota, Shiga toxin, E. coli, and Listeria. Low volume, high volume. Aerobic plate count, and then our S-Tex and our L mono. What you'll notice at the low volume is that you see this difference between the water and our sanitizers, but there's no difference statistically between those sanitizers. With the S-Tex, it's even more prevalent, so there is a significant difference here, not really a difference between the sanitizing agents, and the same over here. But what's interesting to note when you get to the high volume, you'll notice that statistically there's no difference there. So now what you've done is you've probably overwhelmed your system. And so now there's no difference between the water and these sanitizing agents with respect to controlling the microbial load on the product. But remember, that's really not our intent to reduce it on the product. It's to produce cross-contamination. So this is what the heart of this is about. Cross-contamination with just our S-Tex, our Shiga toxin producing E. coli, low volume, high volume, again, water, our different sanitizing agents. And what you'll notice here again is if you just look at this, water, some of these sanitizing agents, we actually had cross-contamination, but when you get into this high volume, look at this. Even in the third soaking, you're getting cross-contamination going on. So that means you've just got these organisms in there and you're contaminating whatever you're doing in that scenario. Similar scenario with the Listeria monocytogenes, but what I'll suggest to you is that if you look at here, overall numbers of cross-contamination, it's a lot lower than what you had with E. coli 15787. So not all microbes are going to behave the same in this scenario. Again, we looked at the water. So we were looking at all types of parameters here. But ultimately, if you look at what's going on, so this is aerobic plate count, this is CFU per 100 mils, our water, and then our different sanitizing agents. And what you'll notice here is in the water, the numbers keep increasing with every successive use of that water. And it's true for the aerobic plate count, the S-Tex, and the L mono. Now, some of these sanitizing treatments were better than others. This happens to be electrolyzed water. We could not find In 100 mils this is. So if we took the whole volume, maybe we'd find something. But we didn't detect our microorganisms of interest, X-Tec and L-mono, in that. So it did a very good job of controlling the microbial load in the water. That's not to say that you still won't get cross-contamination, because why? You have physical contact of the heads of lettuce. So in summary, based on the conditions that we evaluated, we recommend that the amount of commodity processed during a single soaking be appropriate to achieve your desired outcome. So what does that mean? It's highly ambiguous, but the bottom line being is that, understand that if you put a lot of product in there and your desired outcome is to prevent cross-contamination while you're doing this or to reduce the microbial load, that's not going to happen. If your desired outcome is to simply remove physical debris, soils and bugs, that could take place. In this study, we found that this neutralized electrolyzed water was actually very effective. I think the research is intended to provide guidance to the industry. If they so choose, they could look at this and say, well, maybe this is something that we need to consider a little bit more. And then finally, it might facilitate the development of best practices by folks at their various companies if they look at this. What are we doing with respect to the future? We're going to investigate viruses and transfer of those guys, looking at refreshing. And what do I mean by that? Is what I was talking about earlier. So if you use it once, you test it, and then you refresh it if you need to. You just don't keep using it. And that goes back into this monitoring and recording. And then finally, if I got 1 second left, I just really want to thank the folks that were involved in this research here. All what they got out of me was a lunch for this, I know. But really, it's Jingwen Gao, Li Chung Wang, and Sing Lo. They all were involved in this, and actually 2 of the guys are here today, so thank you guys very, very much. And then Haiying Zhang, actually she's down at FDA right now doing a postdoc down there. So it was just a fantastic group to work with. And I think that sums it up. Thank you guys very much.
Thank you very much, Professor Matthews. We do have time for questions. Questions from the crowd?
Okay.
I have a question.
Oh.
So, throughout your remarks on a couple of occasions, you mentioned that you wanted to hear the industry perspective. So I concluded that perhaps you sensed that there's a gap in the information getting from academia to the industry. Am I perceiving that correctly?
Indeed, I think there is somewhat of a gap there. In other words, maybe they're not aware of some of the information or this type of research that we're conducting. And then also I think too, just as academics, we need to be reaching more out to a lot of this research, again, that folks are reaching out and doing is more from the commercial process side. It's not necessarily from what's going on at food service establishments. Yeah.
Well, it's something we can work on together.
Pardon?
We can work together on the communication.
Oh yeah, exactly, yeah.
So thank you. Any other questions?
Thanks.
Well, our compliments in the study and our thank you to you, Professor Matthews, Rutgers University. And on behalf of Jim Prevor, Ken Whitaker, Produce Business, the Eastern Produce Council, and Claire Powell, we want to thank you for joining us for today's micro sessions, and John Pandel for all the great questions you asked. Thank you very much.